哎，大家好啊！欢迎大家来到咱们这个 Substrate Saturday 这个直播栏目啊。然后，我是这个 OneBlock 设计经理 Tracy。然后在今天咱们开始直播之前呢，让我还是先简单介绍一下这个 Substrate Saturday 这档栏目啊。然后咱们这个 Substrate Saturday 呢是OneBlock 旗下的一档这个线上 AMA 的直播栏目。然后 OneBlock Plus 呢就是专注于这个推广这个区块链这个技术。然后以及这个 Substrate 的这个技术的开发者社区，然后是这个 Parity 在亚洲唯一的一个运营合作伙伴。然后 Substrate 呢是由这个 Parity 研发的一个区块链开发框架，使得这个开发者可以更加简单、快速的构建自己的区块链项目啊。然后咱们这个 Substrate Saturday 呢，主要是邀请这个 Polkadot 以及生态项目或者一些工程师啊一起探讨咱们 Substrate 的相关内容为主啊，是一档比较偏技术和深度内容分析的一个栏目。然后呢，对，然后今天咱们这个活动是这个以英文为主啊，但是咱们创流平台的这个同学们呢，应该可以看到一些实时翻译字幕啊，然后大家有什么疑问都可以一会儿就是先提出来，然后会代替大家向老师提问啊。然后今天咱们邀请到这个路易斯老师啊，是这个 Gear Foundation 的开发者关系负责人。Okay, hello everyone, welcome to Substrate Saturday. I'm Tracy, the community manager of OneBlock. Before starting today's live broadcast, please allow me to briefly introduce the program Substrate Saturday. The Substrate Saturday is an online AMA live uh, program under OneBlock. OneBlock Plus is a developer community focused on promoting blockchain technology and substrate technology. And it's Parity's only operating partner in Asia. And Substrate is a blockchain development framework developed by Parity, which allows developers to build their own blockchain projects more easily and quickly. And Substrate Saturday mainly invites Polkadot in these ecological projects and for engineers to discuss substrate-related content. It's a program that focuses on technology and in-depth content analysis. And today we invited Luis. He's the head of DevRel at Cure Foundation. Hello, Luis. You can share your screen and start the presentation.
Yeah, sure. Thank you so much. I'm gonna share the full desktop. Just let me know if you can see it.
Yeah, I see it. Perfect.
Okay, let's start then. Thank you so much. I want to present myself. I am Luis Ramirez. I'm head of the realm of Care Foundation, and today I'm gonna talk about how to build smart contracts in Vara Network. I want to give a brief introduction about myself. The last 3 years, I've been working with developers in the Web3 landscape, organizing, mentoring, and judging projects in different countries. The last three hackathons that I am been part of, it's ETH Mumbai. This was 2 months ago. And now it is Polkadot Hackathon North America, which is gonna finish the next week in consensus. And the Polkadot Prodigy Hackathon that is gonna finish in Bulgaria the next month. Then I like to work with developers just to understand what's new in the ecosystem, providing information about all the advances that Vara Network has for the ecosystem. Then this is basically my background. And you can see here a picture of this year about the team, the Gear Foundation, all the people that is working in a centralized way to provide this technology. And different countries, we give workshops, we have meetups, and we organize hackathons. So here we do have a picture about some events that we have been part of in different countries. Yeah, and it's a really a pleasure to me stay here and Substrate talk because it's going to be really easy to understand for all the Substrate developers the roots from Vara and then the powerful of this technology. So where does Vara come from? Well, actually, our CEO Nikolai Wolf, it's he has been working on the Substrate ecosystem uh, so many times, so many years ago. And as a core engineer at Parity Technologies, he saw an opportunity in the Web3 landscape where developers want to be part of a smart contract platform, but sometimes it's a little bit complicated because you need to learn a new programming language. Like, for example, if you want to enter into the EVM ecosystem, then you need to learn Solidity, right? Or Viper. Then there are some other blockchains that for starting, you need to learn a new programming language like Motoko or something else in the ecosystem. Then something really powerful about the Vara is that the technology provides all that the developer needs if the developer understands one of the different programming languages compatible with this technology, which I'm gonna provide all the pillars and the information related this, but this was the beginning. Okay, so Gear Foundation is actually dedicated for to advancing the development and adoption of the innovative blockchain solutions. And the first technology that was created behind the Gear Foundation, it's Gear Protocol, which is a protocol that can be implemented in different ways as a layer 1, layer 2, even connecting to another ecosystems. Then the first implementation of this protocol is Vara Network, okay? Gear Protocol is based on Substrate. So the roots, it's from this framework. I'm pretty sure that almost all of you understand about this. Just for all the people that is the first time that heard about Substrate, is a modular framework that provides the tools to create modular blockchains based on palettes and creating your own solution in a very fast way. Okay, well, as I said, and I show you some pictures, we've been doing different events in countries like Mexico, US, China, Spain, Turkey, India, and we are growing with the Vara Squad, which is the community that help us to grow the ecosystem and work with universities, Web3 communities, etc. Then, in a simple way, what is Vara? Vara is the next-gen cloud infrastructure platform, and it's a sovereign layer 1 built on Substrate, like a Vara is based on Gear Protocol, right? Then one of the more important elements to keep in mind is that if you know, for example, Rust or assembly, those programming languages on the smart contract side, then you can start learning about how to build a Web3 application, and you don't need to worry about learn something new. This is the powerful of this, but the more important one is that Vara is based also on WebAssembly. One of the three pillars of the Git protocol is WebAssembly. So the idea is that all the developers that understand the programming language compile it based on WebAssembly, they will be able to build on Vara Network. But so far we have already the Rust and assembly script programming language. Okay, and also an important thing to mention here is the persistent memory, which it provides the developers an easy way to interact with the smart contract and the state, because every smart contract has its own state for security reasons, and to create a more complex application based on a modular system, then the persistent memory, it's a good way to start. But also different other things like, for example, CK, which is actually one of the more important things in the Web3 ecosystem. We are compatible with CK technology, building different kind of components on it, and some other smart contracts for all the developers that wants to understand what is different. Okay, yeah, I understand that is substrate based, and also the focus is to bring more developers into the ecosystem, providing an easy API based on Rust and assembly script. After that, you can see different distinctive features on Vara Network. We have here three. There are more, but let's explain the more important ones. Now, the first one is delay messages. Just imagine when you are building an application, a smart contract application, then you want to interact with different components. And after you need that in the time, after the time, some kind of event is triggered just to your smart contract can process this information. In this way, normally what a smart contract platform does is to interact with off-chain triggers. Yeah. Then an off-chain server is sending this information, and after it's processed, the delay message is this feature that avoids to use off-chain interactions, because one smart contract is able to send asynchronous messages to another smart contract, even to the self smart contract, which it means that you can put like a timeout just to wait for some time to pass and after start a new action. But well, yeah, the time in blockchain is related to blocks, and here in Vara Network, one block it's in 3 seconds. So you only need to do some calculations. When you need to send a message after 1 day, after 1 week, after 1 month, then you just set this in blocks, and the delay message will be sent, and after the smart contract will process all these payloads and after this time. Okay, the next one is payless transaction, which provides to the end user the ability to avoid paying with its own token. It means that when you want to test your application, you avoid that the user gets tokens from wherever he or she can get some tokens. And the smart contract developer provide these tokens in advance. How internally each smart contract has one voucher, which this voucher it's like a digital space where you can set tokens, and you can configure it just to let them know to the contract what user will be able to use and with what actions, and also with a timeout. This is important because for security reasons, if you set an amount of tokens there, then you need to understand the business logic and how the users will interact with this. So at the end, the payless transaction provide this feature that avoids the user to pay with its own tokens. And the last but not least is signless transaction. It's a really, really incredible feature that provide trusted sessions just to avoid the user signing the transactions every time that is interacting with the blockchain. You can see it like in a normal Web2 application. The users once is log in into the system, only send information to the network and never sign anything, right? Well, as we know in the Web3 ecosystem, if you want to interact with a smart contract, for security reasons, you need to sign the transaction. But this happens every time that you interact with the smart contract platform. So here, the signless transactions create a trusted session, which internally creates a key pair, a private and public key. And you also set a timeout just to say what is the amount of time when you want to interact with the application without signing. So the user provides the rights to the temporary keeper just to interact with the smart contract platform with this keeper, with this temporary keeper. okay? And this avoids to sign the transaction every time. So can you imagine create an application with payless and signless transaction together? It's basically a normal application where the user will interact with your dApp, but without using tokens and without signing every time the transaction. This is really powerful, and we will see more details about this. But before to start with a practical smart contract, I want to provide all information about the structure. The first thing that we need to keep in mind is the metadata. This is the way that we interact with between the smart contracts when we are sending information. And this information contains all the types that we are sending, and we need to uh, give to the other side. So it's going to be easier to understand what information, what payload is coming. This is the metadata, contains information about this. And all the functions of a smart contract, like init, handle, that I'm going to explain, you need to provide the metadata. Okay. Then after the first method that you need to use in order to initialize the state, if that is the case, if you want it, is the init method. It's a function that you call only once, and after you call it, you never call it again. Okay, then interacts with the states and prepares the smart contract to process all the incoming transaction, all the incoming messages that another smart contract or the front end wants to send. Then the state. This contains the variables necessary for the program's logic. It's the place where you're gonna save the information. Once your smart contract execute an order, then you need to persist this information and you save it into the state. And it's one of the more important things to keep in mind, because you need to create a basic structure about what information you really need to save here. And after saving, also you will return it. Then a key feature about returning information is the metastate, because this is a function that provides the functionality to query the state for free. And then if you implement it, and you can return but the full state of your smart contract, or you can implement some function just to return some parts, specific parts, just to avoid to return all the information through the network. Then we are ready. Once we have this, then we only need to focus on the business logic, which is what will do my application, right? My smart contract will execute some actions. Then I need to provide all the information about what actions and how to process it. This is the business logic, and we have one method that is always listening external events, and this is handle. Okay, the handle is the main method that the smart contract implements in order to receive the payload from the outside and the event. What do you want me to do? Burn an NFT? You want me to do transfer a token? You want me to do some supply chain action, etc.? Then once you return this, you return something for the event, and you want to interact, for example, with another smart contract, that you need to prepare the handled reply. It defines the logic once you receive a message as a response from another smart contract. Okay, then with this in mind, we're ready to start with one single example. I'm gonna open it. Let me check just that you can see this window. Okay. Uh, can you tell me just if you can see the Git the GitHub? just to continue, because sometimes the session hides some windows.
I can see.
Yeah, you can see it?
Yeah.
Okay, thank you so much. Then, well, this is one smart contract example. You can go to the Gear Foundation GitHub, like in this space, and you will find a lot, okay? We have different templates to start from scratch, and also some smart contracts that they're working together with the front end and different stuff. But here you can see a single smart contract structure. Let's open it with the Gitbot. Then it's gonna be easier to explain. Okay, let me put my credentials. Okay, now we're ready. We need to open our workspace. Just to let you know, if you haven't used Gitbot before, this is a platform where you can modify codes in real time on the browser. Then you just need your GitHub account and you can see the project. But if you want to develop your smart contracts on a daily basis, I recommend you to install the local environment. So it's going to be easier for you and you won't depend on the external platforms. But now for this workshop, this is the easiest way. Okay, then I'm gonna put also this window. I'm gonna divide it because I want to explain the structure with this. Okay, on the right hand, we have the structure, and on the left hand, we have the code. So let's go first with the metadata. Once you create a Rust project, you can see here on the left side, different directories. Like for example, cargo.ml is the file where you define all the dependencies for your smart contract. We have a make file in this case because we are gonna compile with make, but this is optional. If you want, you can only use the cargo.ml and compile with normal cargo instructions. Okay, then once I have my dependencies here, and I'm gonna explain really fast what are the most important ones for us. The first is our standard library implemented by Gear, is the Gear standard library. Then this library contains all the smart contract implementations for interact with them through messages, for example, send and receive the messages. The more important structures they are in here in the GST. Then once you want to compile the smart contract into a WebAssembly file, binary, then you need to use the Gear WASM builder. And once you implement your metadata, which is one thing that we're gonna see with detail now, you need to use the gmeta. And this scale info and parity scale codec are libraries that we need to use in order to encode and decode information to the network. And well, the TMG IO is the directory where we're gonna save our metadata information. So let's check this. On the left side, the IO source and lib.rs. Here we will define our metadata. As you can see here, we have the implementation, and this implementation, it provides information of 6 methods, how we will send information to each method. For example, in the init side, the first stage, do you remember? Well, you have it also here on the right side, init methods. Then I said that you can interact with this to initialize the state. Then you can provide information about what information is gonna enter into your function, and after you process, if you will return, what kind of information you will return. In this case, you will receive a string and you will return empty response. Okay, that's why you declare in out here. The handler, which is the method that we are use in order to process all the incoming events. Here is also in out, then the input is the TMG auction. Okay, then let me explain what this smart contract needs to do. Tamagotchi is a digital pet that you can feed, you need to sleep, and you need to interact with just to avoid that this digital pet died. Then action in the handle method, it will provide all the information that you need to send in order to interact with your digital pet. Okay. For example, here our TMG action is what actions I want to send to my digital Tamagotchi. Yeah, I can send name just to ask what is the name of the Tamagotchi. I can send age to ask the age of my Tamagotchi, and like that. I can feed, I can play, and I can sleep with the Tamagotchi, and also I can get more information about this. We can see here TMG info, and down we have it here. TMG info basically it returns the owner name and the date of birth of our Tamagotchi. So it's information, okay? Then, well, we have here the handle, and we understand that we send the TMG action just to interact with our Tamagotchi. And after the smart contract process my event, it needs to return a response, right? So this is the TMG reply. And it's exactly the same, but with information to return to my frontend or to my smart contract that's called the initial smart contract. Then we have a name. After, if the user requests the name, then I will return the name as a string. If the user requires the age, then I will return the age as an integer 64. This is integer, but it's an unsigned because we are returning milliseconds, right? Like the difference between the timestamp and the milliseconds and when it was created or Tamagotchi. And feed, entertain, and sleep are actions just to express that we already execute the event that the user requests. Okay, then the state is the more important thing just to keep in mind what information you're gonna persist to your smart contract. And you can see it here on the right. And the state is this big rectangle that interacts both with the init and the meta state. And also the state interacts every time with the handle because it's more important information that you're gonna save into your smart contract. Then you can see here that you have an input and output. You don't receive nothing, but you will return a structure called Tamagotchi. And we can see here on the last part of our file. It's easy. It's easy, this structure, because we need to understand only what it's gonna do our smart contract, and we will provide the information and the variables to save this. For example, my Tamagotchi will contain a name, is the name of my Tamagotchi, the date of birth is the age. I can calculate here the age of my Tamagotchi, who is the owner, and we have an actor ID. So this is important to keep in mind because an actor in the Vara ecosystem is the smallest computational units, then everything is an actor inside the network. And this is really powerful because you can only send and receive messages through these actors. And in this way, you can create really powerful applications, modular applications. So every time that you are interacting with a user, with a smart contract, with a wallet, with a bridge, all of this in the Vara ecosystem, they are actors. Okay, that's why the owner of this Tamagotchi, that is going to be the one that uploads the smart contract into the platform, is an actor. And we define this as an actor ID and all other information related to my Tamagotchi, just to know when I need to execute one action or if the Tamagotchi is still alive or not. Also, all with auctions, just to what users will have some kind of rights to execute some kind of actions. Okay, then once we understand the metadata, it's going to be easier to interact with the different methods because we know what information we're going to provide. So let's check where and how to implement each method, okay? On the left side, we also have the source directory, and inside the lib.rs. Then here in this file, it's the main file where we are gonna set our variables, initialize them, before to start all the business logic. Okay, so these are my variables that contains all the information that I need to have in order to interact with my Tamagotchi. And here we are using the creds, as I explained, like GSTD, the standard library to send the receipt messages and to interact with the main data types for the smart contracts. And we are also using the metadata, okay? And let's see this part. We are declaring here a static mutable variable with the name of Tamagotchi, and it's as an option with an structure of Tamagotchi, like the same structure that we defined previously. This is our state. On the right side, we can see here our state, and it's the more important variable in our smart contracts because we're gonna save here the information, and after we can query all this information with this variable. And it's static and is mutable because the static and the heap are persisted, but the stack it is not. So the stack, you can see it here. Let's see, for example, one single method in the init here. These variables that you declare inside a function are saved into the stack part. So all these are not persisted, but the static, it's a variable that it's persisted. Then that's the reason why you're gonna declare it here outside the functions, and it's your main structure where you're gonna save all the information, okay? Then let's see, for example, the two more important methods. First one is the init. So let's search the init method. It's here. Then we declare with this signature unsafe external C and the name of the method. This is a public function that the front end will call and send messages. But just remember the init, it's execute only once. And when you send a payload, then you can get it with the MSG load we'll see here in the handle, okay? This function, it helps us to get the payload and process it. Then the init method, well, we don't have payload here unless we don't have declared under code. But as we declare that we can receive a string, then you can put here like this payload will come from as a message, as a part of the message. And here you only define a fixed payload, like it's the name of the Tamagotchi, then you don't load information here, but you will be able to do exactly the same thing here. For example, if you want to receive this string, instead of put this, you can put this, and this it's a string, and you can receive here your Tamagotchi name. And if an error occurs, then you will just send a message about this error. But in this case, we're not using this line. We're just setting the name. It's fixed. And if you want to change, just to interact with the platform with your own Tamagotchi name, you can just change here. So TMG workshop. And that's it. Okay, this is our init method where after receiving our payloads, we can initialize our state. Do you remember this? It's interacting with the state. Then we only initialize and save inside our state. Tamagotchi is the variable that we declare on the first part of our smart contract here. Then, well, the init just initialize some variables, and after you can just pass this to your state, which is Tamagotchi. And the other method, the more important one, once you want to interact with the smart contract, is this one, handle, okay? The handle is ready to receive information from the outside. Then you need to load it first with the MSG load function and declare what is the data type that you are expecting. This is the reason why you use metadata, because you defined previously what kind of uh, data types you will use to interact with your smart contract. In this case, it's about a TMG action that it could be name, it could be age, feed, play, sleep, and TMG info. And you just need to match the action with one of the enums declaration. This name is an enum. And once it match, then you just set the code inside to execute what you need the smart contract does. And if you can see it here, it's really easy to understand that in a single way, all the messages, all the events that you want to send to your smart contract, it will be processed here in the external handle. Okay, then let's just prepare an environment just to get our files to upload into the blockchain. Then we need to initialize our environment with make init. As I said before, make it's optional. If you use makefile, then it's okay. But if you don't, with single cargo commands, it's gonna be fine. Okay. Then let's compile our contract. This process will compile all the libraries, and you will see that there are a lot. But this is one of the more important things when you are developing on Vara, that you have different libraries that provide different functionalities and avoids the programmer to start something from scratch and interact with some complex terminologies, like, for example, asynchronous methods. You don't need to worry about to implement this. You only need to use it and just set the keywords, async and wait, in order to interact with this functionality. Internally, the libraries execute all this, and you don't need to worry about it. And also, for example, if you want to use some libraries, standard libraries, that is going to be really good, because this is Rust. Mainly is vanilla Rust, which it means then that the smart contract, it's not a single smart contract, it's a smart program, because you can execute the code not only on blockchain platform, but also on a single machine. If you have code standard Rust with some libraries that it's also they are standard, then it's gonna be really easy to port your code to other platforms. Then sometimes, for example, if you want to test some complex functions, you can do it on your computer and after pass this code to your smart contract if you use a standard vanilla Rust and the right libraries. Okay, we are done. And just to finish this, I want to explain what is the output and how to use it. Once you have your smart contract compiled, you will have on the left side target, WASM 32, and release. You will have different files. The more important ones to upload it into your smart contract platform is the metadata, this tmg.meta.txt. It's an hexadecimal file that declares your metadata. And the tmg opt.wasm, it's our optimized WebAssembly file that is ready to be uploaded into the blockchain. So once you have these files, then you will be ready to upload it into the idea.gear/tech.io. And you just need to choose the network. The network, you can use mainnet when you have tokens, but if you don't have and you want to interact with the network with faucet and all the testing tools, then you just need to connect one of the wallets that are compatible. As you can see here, Polkadot's wallet, Talisman, Encrypt. And once you connect the wallet, you use one account and you use this upload program button. Then you just select your file, for example. And once you select your file, you will see on the right side your metadata. You can set the name of your smart contract, like a workshop TMG, and here the name of your Tamagotchi, TMG Gotchi. Calculate the gas that you need to use and upload the program. So that's it. Once you execute all this process, you will have the smart contract into the blockchain ready to receive messages. And you can try it here in the same idea, sending messages through the program section. Now I'm gonna show you really fast here in my programs. This is my uploaded smart contract. And you can just read the state, for example. Just remember this is free. And you have here all the state that you declared before. And also you can send messages like if you want to interact with your smart contract here and test some of the functionalities, you just enter and send like, give me the name, calculate the gas that you need to pay in order to send this message and sign the transaction. And that's it. You're going to get the name in the messages section here. So it's we just need to wait, and this is our message that send us the name of the Tamagotchi. Okay, that's it on my side. Thank you so much for everything. Then we are ready for questions. If you have something that want to be, if you want to ask whatever related this, I'm ready for you. Then thank you so much for your time.
Okay, thank you, Luis. Yeah, I guess if you have any questions, you can make a comment and forward to Luis. Okay. Give another like 5 seconds.
Yeah. Okay, let's see. If also meanwhile, I can just show you that if you want to keep in touch with us, you will always be available to do it. Here you can see the details of the Twitter, official Twitter, Vara Network, also the GitHub to check all the smart contracts that Give Foundation provides for the developers, and my email. If you want to interact with me, then you only need to send me a mail, and we can talk about the project, about technology, and all that stuff.
Okay, I got several questions. The
Yeah.
first question is asking like compared with other like blockchain networks, what are the like unique advantages in Vara networks architecture?
Yeah, I will say that are this one, like I explained at the beginning, the first part of the session, the delay messages that avoids to use off-chain interactions, the payless transactions that avoids the end user to pay the gas fees on its own, and the signless transaction that avoids to sign the transaction every time that user interact with the blockchain. Those are really distinctive features on the end user side. If you want to understand, for example, distinctive features on the developer side, then I can tell you compare with other smart contract platforms. And mainly if we compare like the smart contract platforms that use some kind of technology like Rust, for example, or WebAssembly, then interacting with the Vara network ecosystem for a developer, it's really easy. Even though you have or you don't have a background on the Web3 landscape, you just need to understand the basis and you can build really fast on the network because it was thinking that developer only need to worry about the business logic and not about the complex concepts before to start with this platform.
Okay. The second question is about like a security question. It's
Yep.
saying, does Vara Network provide any built-in security audit tools or third-party service integration to help developer check smart contract security and vulnerabilities?
Yeah, absolutely. We have different stage on this. Like, for example, if you want to build a smart contract on Vara Network, then you pass for a process like to get a grant, for example. And we help to all the teams building on Vara Network with a grant, starting from the educational side. And after also with this process, we help with internal audits. This is performed by the team. We help them to understand whether the code is good or not. And also, we work with different companies to audit the code. But this is a process that we talk with the teams, then just to understand in what stage we are and how can we provide this for them in order to have a really secure code.
Cool. Then last questions. Um, does Vara Network support cross-chain interoperability?
Okay, this is a good question because Vara Network it's an isolated blockchain based on Substrate. Okay, so let's think about this. You can build different blockchains with Substrate, and you need to focus about what is your key feature. Then the interoperability for Vara Network, it was not the first thing to keep in mind once the technology were built, because the speed of the network, the security of the network, it was one of the key features. But we need to see the base of Vara Network, which is Gear Protocol. Okay, Gear Protocol, it's you will be able to build whatever you want with Gear Protocol. And if you want to interact, for example, with other ecosystems, then if you use Substrate, then you just need to interact with the technology that provides Substrate in order to interact with other blockchains. As we know, Substrate is the base of the Polkadot ecosystem, and you can send different messages not only to the parachains but also to external blockchains using XEM. And then this is obviously possible if you use Gear Protocol and you interact with these messages, you will be able to do that. Yeah, that's for sure with Gear Protocol.
Then so far I didn't see any question. Luis, would you be able to like share the QR code again, so people, if they
Yeah.
have questions, yeah, you can scan this code. Uh, okay, then I'm going to share my QR code. Da, da, da. Okay, yeah. So thank you, Luis, for your wonderful sharing today. Okay, and I believe, oh, also, Luis, be able to like send us your like PowerPoint through our
Yeah.
group, so we can write some articles based on that. Okay,
Yeah, sure.
cool, cool, cool. So thank you so much, and I believe everyone has a new understanding of Vara. So if you're interested in today's contents, you can also go to the